Hi students, so welcome in today's lecture. In today's lecture we are going to talk about a previous year JEE Advanced 2020 question. It is based on the surface tension. So and it is very much related to the uh, Young Laplace equation for the excess pressure. Okay, so first we need to understand this concept of the how do we apply the Young Laplace equation. So like you must know this equation that the pressure difference according to the Young Laplace equation for the drop is T times of 1 by R1 plus 1 by R2. Okay, this is the pressure difference. uh, like we know that the pressure difference for the drop is 2T by R, so something like this. Here we have T 1 by R1 plus 1 by R2. Okay, now here what is 1 by R1 and 1 by R2? What is R1 and R2? That is the radius of curvature of the surface. Look, generally when we take a spherical surface we will just have one radius of curvature. All right, like for example, if I take any sphere, so if I just take the part of the sphere, so then the every point of view we will have just one radius of curvature, right? And but instead of that, if I take a surface, like let's suppose we have this surface with me, right? So now this surface can have two radius of curvature. How it can have two radius of curvature is like if I take this surface right now, you can look that this is a just a flat surface. We can take it like this, right? Now this radius of curvature can be one radius of curvature can be like this. Okay, if you look from that side, so you can see right now one radius of curvature, this radius of curvature. The another is this surface is also having a radius of curvature. Right now this radius of curvature is infinite. Okay, I can also fold it slightly like this. Okay, let me just try to make it. So look, this surface can have two radius of curvature. One is from the side, if you look, so this is one radius of curvature. The another radius of curvature is there in this side as well. Okay, so like this is surface, because surface is made out of two dimensions, right? Two linear dimensions, and linear dimensions can be bent, so that is why a surface can have two radius of curvature. So because of that, the pressure difference is for a surface we can give for a liquid drop we can give is T 1 by R1 plus 1 by R2. This concept we are going to apply for this question. So this question is a very nice question, right? They are saying that when a water is filled carefully on the glass, one can fill up to h height. You can read this question. Calculate h just about flowing. So to calculate just before water starts flowing, model the shape of water above the rim as a disc of thickness h, having semicircular edges shown symmetrically in the figure. When the pressure of the water at the bottom this exceeds what can be withstood by the surface tension, then water breaks near the rim and starts flowing if the density of water surface, and these are the values. So then we need to find out the h value. So simply they are saying that look, we take a water glass and if we fill it, we can fill it beyond a value. Okay, so this is the upper brim of this glass, we can fill it even more than that, right? So how much we can fill? They are saying that we can fill h height, and this h height we need to model it like a disc. So of course if you look from the disc side view of the disc, it will look like a rectangle, but they are saying no, it is not like this. These edges are semicircular edges like this. Okay, so you must have eaten a sweet like that, so kind of. Okay, so now they are saying that to find out this h, look, there is going to be one pressure variation because of height difference. So let's suppose the pressure here is P naught. So pressure here is going to be P naught plus rho GH, and another pressure difference is going to be because of the this surface. We have concave side, this side is a concave side, and this side we will have a pressure difference of T 1 by R1 plus 1 by R2. If this excess pressure is equal to this, so then of course that height is possible, but if this pressure exceeds then this value, so then it will break. They are saying like this, so we need to find out what is the H value. So look, what I can say is we can equate the pressure, excess pressure, because of the drop surface and because of the height variation rho GH. Okay, now we need to first figure out what is the R1 and R2 value. So for this they have, for the R1, for this radius of curvature, they have said something here that we need to take that shape of water above the rim as a thickness of edge having semicircular edges. So we need to take it as a semicircle. Okay, so this diameter becomes 2R1 and diameter becomes equal to the h height. So R1 becomes h by 2. So R1 we got it, R1 is h by 2. Alright, what about the R2? So R2 is actually this radius of curvature. If you look from the top, it will look like a disc like this. If you look from the top view, and this disc will have the radius of curvature of this glass, which is R2. R2, we can say that R2 is very high compared to R1, so we can consider it almost infinite, or otherwise we can say 1 by R2 is almost 0. Okay, this they have not said in the question, but I am taking according to the practicality. Look here, generally we will take the glass of water that will have a lot of radius of curvature, so because of that 1 by R2 becomes 0. So T multiplied by, instead of R1 we have h by 2, so that becomes 2 by h is equals to R rho GH. Okay, so h square value is going to be 2t divided by rho g, and we can just substitute the value. So h square is 2t. 2t value is 0.07 divided by 10 to the power 3, 10 to the power 4. Okay, so that's the value. All right, so h square value is going to be 2 to 14 and 10 to the power minus 6. Okay, so if we take the square root of this, okay, so the square root of this value is root 14 10 to the power minus 3. This comes out to be approximately 3.74 mm. So this much height difference will be there. Okay, so till this much height we can fill it. Alright, so I hope you must have understood this logic. This is our Young Laplace equation, and there are the other videos available on the channel. You can also watch the other videos and get to know about the other concepts. Thank you.